Hello everybody and welcome to a brand new YouTube video. So it's been a while since I've done a kind of beginner project, something that really anyone can follow along with regardless of their background in Python, and so I wanted to do one for this video. So what I'm going to be showing you how to do is actually create a graphical application. So this is not just going to be text, although it looks like that right now. And what's going to happen is we are going to create a turtle racing program. So essentially the user will be asked to decide how many turtles they would like to race. Based on their answer, a screen will pop up, as I will show you in 1 second, and then it will race that many turtles by just randomly moving them on the screen. Now, this is a great project to learn about how to build something a little bit bigger than a really simple Hello World application. I guarantee if you're new to Python, you're going to learn a ton here. I purposely used a bunch of different syntax and functions and kind of showed you how we can lay out a relatively large program for beginners. This is not a large program by any means, in kind of a nice structured way where everything is just done in kind of the proper format. So anyways, let's go ahead and get started here. I'm just going to show you a demo of what we're going to be building. So it says, welcome to Turtle Racing. Please enter the following information. How many turtles would you like to race? You can enter between 2 to 8 turtles. I'm going to select 8. When I do this, it's going to open up the turtle window. This is built into Python. There's nothing fancy you need to install. It's going to initialize all of our turtles, and then it's going to start racing them on the screen. So it looks like the red one is going to win here. Let's see. And oh, maybe not. So it says here, the winner of the race is pink, and then it waits 5 seconds and then it stops. Now I will show you how we can run this multiple times if you'd like to do that. That's the basics behind this program. Now let me show you one more time. If I race, say, 3 turtles, notice how they are evenly spaced out on the screen. So I'm going to be showing you how we can do that. And there you go. They race. Nice. And it says the winner is orange. Awesome. So let's dive into this video after a quick word from our sponsor. Before we get started, I need to thank the sponsor of this video, which is AlgoExpert. AlgoExpert is the best platform to use for preparing for your software engineering coding interviews and has the highest quality coding interview practice questions. With over 140 practice questions, detailed solutions in 9 of the most popular programming languages, a feature-packed browser-based coding environment, extensive test suites, and conceptual overviews and code walkthroughs for each and every problem, AlgoExpert is the best resource to use to ace your coding interviews. AlgoExpert also has a data structures crash course, coding interview assessments, and a mock interviews feature. I can highly recommend AlgoExpert as a former customer myself and now an official instructor on the platform. Get started using AlgoExpert today by clicking the link in the description and using the code TechWithTim for a discount on the platform. All right, so let's get started by talking about what you're going to need to follow along with this tutorial. You are going to need some type of code editor and an installation of Python. Those are the only requirements here. So if you have Python already installed on your system, which I'm assuming all of you do at this point in time, then open up your favorite code editor. It could be Sublime Text. That's what I'm using right here. Or if you're not even sure what I'm showing you, you've never seen this window before, you don't even know what I mean by text editor, just open up your standard IDLE. Like this. And for you to follow along with me here, just go to File, New File, write all of your code in a file like this, save it with some name. It's very important that you do not name your file Turtle. Do not name it Turtle. If you name it Turtle, you can potentially have some problems. And you're going to go in here, save this file as whatever you want that's not named Turtle, and save it in whatever location you want. And then whenever you want to actually run your code, when you're inside this file, you can press the F5 key on your keyboard, or you can go to Run and then press Run Module, and well, that will run your Python code. Now, I'm going to be working in an editor called Sublime Text. This is a free text editor. I'll leave a link to it in the description. What I've done here is I've created a new file. It says turtle race tutorial.py, and the way I'm going to be running my file is from my command line. So I'm going to go to my CMD. If you're on Mac, this would be your terminal. I'm going to use the Python command followed by the name of my file. So in this case, it's going to be turtle race and then tutorial.py, and then this will actually run my file for me. Notice I've saved my file on the desktop. That is why the path for my command prompt is on the desktop. Hopefully that gave you enough information so that you are confident to follow along. If all of this makes no sense, just open up IDLE and just write Python code as how you normally write it. You don't have to work in this text editor that I am here. Anyways, let's go ahead and get started. So the first thing that I want to do here is I want to ask my user to input the number of turtles that we are going to have. So what I'm actually going to do here is I'm going to create a function If you've never seen a function before, I'll explain them. They're pretty straightforward, but I'm going to say define, and the name of this function is going to be get underscore number underscore of underscore, and then we'll say racers like this, or turtles, whatever you want to call this. And then inside of here, this is where we are actually going to ask the user to insert the number of racers that they want to have. Now, the reason you're going to see me kind of write things in this way in different functions and kind of different blocks is because it really separates out what every single aspect of our program is doing. And it's just good practice when you're writing code to really have all of the different separate things happening kind of in different areas. So later on, if something goes wrong or you want to add something or change something, it's really easy to do that. You're not looking through a huge mess of code, and well, you'll see how this kind of evolves as we go through here. So what I want to do is I want to ask the user for a number. So I want them to insert a number between 2 and 10. And so I also need to validate that the number they're typing in is correct. So what I'm going to say is racers is equal to 0. And then I'm going to say while true. Now, the reason I have a while loop here is because I want to continue to ask the user to insert a number until they insert a valid number. So if they insert something invalid, then I'm going to keep asking them and say, hey, no, that wasn't valid. Give me something that's valid, because we can't start our program until we know how many turtles we're going to be racing. So I start with racers equals 0. I say while true. Now I'm going to use an input. So I'm going to say racers is equal to, and then input like this. And I'm going to say enter the number of racers, and then I will do kind of a little 2 to 10 thing here to indicate the fact that I would like them to type a number that is between 2 to 10. Now, you don't have to do it like this. You can write whatever you want. This is what I'm going to prompt the user with. And then notice that here I've added a space. So after my colon, I have a space. The reason I have a space is because the user starts typing immediately after this prompt. So this text will be printed to the screen. So I want to separate it from the colon so that it doesn't look like they're typing like right beside this line. There's like a little bit of a space. Anyways, what I'm now going to do is I'm going to check if this, what they inputted, is a number. The reason I need to check if this is a number is if the user didn't input a number, obviously that's invalid, but also I want to convert what the user types in into a number if I can do so. So in Python, by default, when you use this input statement, it's going to capture whatever the user types into the console and convert that into a string. So we need to take that string and potentially convert that into an actual integer, a numeric value, so that we can use that in our program. So I'm going to say if racers dot and then is digit. This is a method you can call on strings, and this will tell you if the string is completely numeric or not. So if the string is numeric, then what that means I can do is I can convert this into an int. So I can say int racers. If you tried to just do this line without checking beforehand if it was numeric, then this would crash the program, because if you had a string that was typed in that was not numeric, you try to convert, say, int of Tim to a int, right? You're trying to convert the string Tim into an int. This is invalid. That's going to crash. You can't do this. So anyways, let's move on now. If this is not the case, so if the racers are, or if what the user input, is not a digit, then what we want to do is tell them, hey, this is invalid. Please try again, right? So I'm going to print and say input is not numeric, ... try again, ! And then I'm going to say continue. Now, what this continue does is immediately brings me back to the beginning of the while loop. So we don't really need this continue. Well, we will based on what I write next, but think of it this way. As soon as we hit this statement, it immediately jumps right back up to the top of the loop. So anything below this, say I had a print statement saying like print hi, this print statement wouldn't run if we hit this continue before this print statement. So that's why I have the continue here. All right, so if the racers is a digit, so if what they inputted is a digit, then we are going to convert it into an integer, which is valid. Otherwise, we'll tell them it's not numeric. They need to try again, and then we'll continue. Now, if we make it past this, so we don't hit this else, and we did make this conversion, now we want to check if this number is within the range of 2 and 10. So I'm going to say if 2 is less than or equal to racers, less than or equal to 10, then what I will do is I will just return the racers like that. Otherwise, I will tell them that this number is not valid. So the idea here is I check if racers, which is now a number, that's why I wanted to convert it to a number so I could do this comparison, is less than or equal to 2 or less than or equal to 10. So if it's within our range of 2 to 10, this is fine. What I will do is return racers. So whatever the user typed in, we're going to return that from this function, which means whatever called this function will now have access to it. Otherwise, though, If this was not valid, what I want to do is I want to print number, not in range 2 to 10, try again, exclamation point. And then I could put a continue here, but there's really no need to do that because nothing comes after this continue in this while loop. And so by default, we will just go back up to the top. The reason I had the continue here is because I don't want to check if the number that is not a number, right? So what the user typed in, I don't want to check if that's between 2 to 10, because if I do that and we haven't converted this into a number, we're going to get an error. Let's say, what the user typed in again was Tim. I can't check if 2 is less than or equal to Tim. This is just undefined. This operation makes no sense. And so that is why I'm continuing to make sure if I don't get a valid number, I don't do this comparison and crash my program. All right, so now we have this function. So I'll show you how we can use this, right? We can just call the function, so get number of racers, and we can say something like racers is equal to get number of racers, and then we can just print out racers down here. Now what will happen is all of the code that we wrote inside of here, notice it's indented after the colon, right? It's going to run all of this code when we call the function. And then as soon as we hit this return statement, what will happen is we will actually return back to where we called this function. So back to this line, and we will pass whatever the value of racers was. So racers will be equal to down here, whatever is returned from this line. So whatever number the user typed in that was numeric in between 2 to 10. Then I'm going to print out those number of racers that the user typed in. And that's kind of the start of our program. Then we've got a few more steps to do after that. So let's try running our program. I'm going to say Python turtle race tutorial.py. Again, if you're in IDLE, just press F5 and come on, enter. Is this going to work? Okay, something's wrong with my terminal. Python turtle race tutorial.py. Okay, enter number of racers 2 to 10. Let's enter 5, and then it prints out 5. Now let's try something invalid. Let's try Tim. Now it tells me input is not numeric. Try again. Let's try Joe. Not numeric, try again. Let's try 11, number is not in range. Let's try 10, boom, that works, we get 10. Awesome, so this is indeed working. We just did a few tests here, and you can see that down here we are getting access to whatever this function returned. So now that we have the number of racers, what we want to do next is actually set up our turtle screen. So I will show you what I mean by that, but let's start by importing the turtle module. So the turtle module is built into Python, and this allows you to perform very basic 2D graphic operations with this thing called a turtle. So you'll see it in a second, but essentially it's like a little kind of header on the screen, and you can kind of move it around. It will draw lines, and it's a really great way to just learn the basics of Python in a nice visual way. So now we have the number of racers. Now we've imported turtle, and let's actually just see what happens now when we run the program after importing turtle. So we're going to run this. Let's import our number of racers. We can go 4, and we actually see that nothing happened. I was thinking the turtle screen might pop up, but I think it's because I haven't used this module yet. So anyways, that was a poor example. What I'm going to do next is show you how we can create a turtle screen. So ignore that last example. What I was expecting to happen didn't happen. Oftentimes when you import a module, like something will happen when you import it. So what I'm going to do now at the top of my screen is I'm going to define, first of all, the width and the height that I want my turtle screen to be. So usually whenever you're working with graphics, you need to define the size of a screen or the size of the canvas you're going to be working on. So in this case, I'm going to say in all capitals, width, comma, height is equal to, and then 500, comma, 500. If you haven't seen this notation before, this means width is equal to 500, height is equal to 500. You can separate as many variables by commas as you want, and then do the assignment with commas as well. So the reason I'm doing this in all capitals is because these are constant values. So in programming, whenever you have a constant value in a language where you can't explicitly define that, you usually have all capital letters to denote the fact that this value width and this value height will never change. They're just here so that we have easy access to the width and the height. All right, so now that we have the width and the height, we want to set up the turtle screen. So we're going to start by creating a screen. So we're going to say screen is equal to, and then turtle dot, and then in all capitals, screen. Now what this is going to do is initialize a screen for us with this turtle module, and then we can kind of set some properties of this screen, the first of which is going to be the width and the height. And so now that I have my screen, I'm going to say screen dot, and then this is set up, and here we're going to pass the width and the height. So this method right here takes 2 arguments, a width and a height of the screen, and then it makes the screen that size. So now that we have that, let's run the program and let's see what we get. So Python turtle race.py, and notice you can see a screen pops up here immediately, and then it's asking me to input the number of racers. So I can input, say, 5, and then the program ends and the screen automatically closes. Great. But when I do this, notice that we get Python turtle graphics as the name of our window. We might not want that. We might want to change the name. So let's actually go ahead and do that. So I'm going to close this. Probably should have left the CMD open, but that's fine. And now I'm going to say screen.title. And in here, I'm going to put whatever I want the name of that window to be. So I'm going to make mine turtle racing exclamation point. Now let me go and open up my command prompt again. You can kind of ignore what I'm typing. I'm just trying to get to where my file is. So Python turtle race tutorial.py. When I run this, notice now the title is changed to turtle racing. Awesome. So let's just input a number and end the program there. Let me make this guy a little bit smaller. Okay, so now we've gotten the number of racers, we have set up the turtle screen, and what we want to do next is actually create our turtles, right? We want to start racing them on the screen. So I'm going to start by showing you kind of the basic commands of a turtle, so how you kind of move a turtle around the screen, some of the things that are associated with it, and then we'll create a bunch of different turtles and then obviously race them. So what I'm actually going to do though is I'm going to take all of this code related to the turtle stuff, so the screen setup, the screen title, all of that, and I'm actually going to move that to underneath where my racers are. And in fact, I'm actually going to make a new function. I changed my mind. I'm going to call this init underscore turtle. And inside of this function, we're going to set up everything related to our kind of turtle screen. Now, the reason for this, again, is that we just want to kind of structure our program nicely, so we won't show the turtle screen until we call this init turtle function. So after we get the number of racers, then we can pop up the turtle screen, because I don't really want it to be shown until we've picked the number of turtle racers that we have. So after we get the number of racers, we can say init turtle. That will just run all of the code in here, so we'll set up our turtle screen. So let's actually go ahead and run this, and let's see what happens. Notice that the turtle screen hasn't popped up this time, but then when we type 4, it kind of popped up really quickly and then it closed, because as soon as we pop it up, the program ends. There's nothing more that we need to do. We're on a good start now. That's kind of what we wanted to do. Okay, so now I'm going to show you how we can kind of move a turtle around the screen. So to do this, you need to start by creating a new turtle object. So to create a new turtle object, what you need to do is say, and in this case, we'll just say racer is equal to, and then turtle dot, and then with a capital T this time, turtle. So what this will do is actually create kind of a drawing object for you on the canvas that you saw, that white canvas that popped up. And then what you can do with this is you can move it around. So I'm going to say racer dot, and then just to show you one method you can use forward, I'm going to move it forward by 100 pixels. Now I'm going to do something here that may seem a little bit confusing, but I'm going to import a module called time at the top of my program. And down here, this is really the only new code that we've added. Right after I move my racer forward by 100 pixels, I'm going to say time.sleep and then 5. What this will do is pause the program for 5 seconds so that after we move our turtle, we have a second to actually see where it went. We don't just immediately close the turtle window. Although we may or may not do that, immediately close the turtle window. Anyways, we'll see here after this happens. So let's run this code right now. And let's see what happens. We'll say 4, and then notice it opens this turtle window, and then it moves this kind of pointer over here by 100 pixels. And then it closes, obviously, because now we are no longer sleeping. So hopefully that kind of made sense, but you would have seen, let's run this one more time, that it opens up the window, it moves our little pointer here, which funny enough isn't actually a turtle, right? Over 100 pixels, and then it closes. So this is one of the methods you can use with your turtle. The turtle will start in the middle of the screen. The turtle is really that drawing kind of arrow that you saw, and every single time you move it, it will create a line. So you don't only have to move it forwards, you can move it backwards, and you can also change its direction. So you can set it to move maybe in 90 degrees. You can set it to go left. You can set it to go north, east, west, whatever direction system you want to use, you can set it to go in that direction. So I can say racer.left, and then I can make it go left by 90 degrees, and then I can say racer.forward, move it forward 100 again, and then I can say racer dot, and then let's just go left. We can go left another 90 degrees, and then we can say racer dot backwards. Is it backward or backwards? Well, I guess we'll see when we run this, and then by 100 pixels. So let me run the code now, Python turtle race.py, and there we go. Oh, so it's saying turtle object has no attribute backwards. That is because this is backward, not backwards with the S. So just don't add the S for the plural there. And let's give this a shot now. So Python turtle racer, and there you go. That's what happened. See, we went right, we went straight, then we went left, then we turned left again, but then instead of going forward, we went backwards, and so we went the other direction. So you can kind of mess around with these, forward, left. There's also right. And inside of these methods here, what you're placing is, at least inside of the right method, is the angle at which you want to turn the turtle. So if you want it to turn 90 degrees, you put 90. If you want it to turn 180 degrees, you put that. If you want it to turn 45 degrees, you put 45. I'll let you guys mess with that on your own. And then this, the number of pixels, is, well, how far you're moving the actual turtle. So when we open up the turtle window, and let me time.sleep for, say, 20 seconds here, just so we have lots of room, so I can explain kind of the coordinate system. So let's run this. Let's open up the turtle window. All right, so this turtle window is 500 by 500 pixels. So the height is 500 pixels and the width is 500 pixels. Now, the very middle of this turtle canvas, it has the position of 0, 0. So the top of the canvas has a position of 250. The bottom of the canvas has a position of negative 250. The left of the canvas is negative 250, and the right of the canvas is 250. Let me open this up again. The way this works, right, is that if the middle is 0, 0, and we have a height of 500, then the top Y position on our canvas, when we're talking about just a standard 2D graph, is going to be 250, whereas the bottom Y position is going to be negative 250. So as you increase your Y, you go up. As you decrease your Y, you go down. As you decrease your X, you go to the left. As you increase your X, you go to the right. Hopefully that makes sense. And again, negative 250 and positive 250, the reason that's the top and the bottom is because the height is 500. I just divided 500 by 2 and then applied a negative to one of the bounds. Hopefully that's making sense, but that is the coordinate system. The reason that's important is because when I say I move 100 pixels, well, we need to understand where that's actually going to move us to and what scale this is on. So when I'm moving 100 pixels, I'm really moving 1/5 of either the height or the width of the screen, depending on the direction that I'm moving in. So we're going to race our turtles going up the screen, but you could totally race them going to the right, going to the left, whatever direction you want. Now, a few more methods that are useful when we're talking about turtles here are things like the actual icon that's representing the turtle, as well as the speed of our turtle. So what I can do here is I can change my racer speed. So I can say racer.speed and then set this equal to, say, 2. Now, let me actually check what the racer speeds are. Okay, so I just checked what the different turtle speeds are here. You can see that these are the potential speeds we have. So we can insert a speed between 0 to 10. And let me just show you this method again. We have the turtle object that we've created, dot speed. So we can set the speed of it to be slow or fast because you kind of saw how it was moving around the screen, right? So if we go here, let's go back to Google. We can see 0 to 10, where 0 actually means we're going the absolute fastest we can possibly go. 1 is the slowest, and then 10 is fast. So really it's 1 to 10, and then if you input 0, it's saying just go as fast as the turtle can possibly move. So let's try putting in a value of, say, 2 or even 1, and let's see how slow this turtle gets when I change its speed. So I change its speed, let's run, and now notice it's moving much slower than it was before. There we go, that is our turtle. Oh yes, it's going right now because I put that right 90 degrees. Awesome, so let's wait for this to close, and then I will show you that we can change, say, the color of the turtle, and we can change what the actual icon looks like and all of that. In fact, I'm not going to wait for it, let's just do it now. So if I want to change the icon of the turtle, what I can do is say racer dot, and then I believe, I'm actually going to have to look at my other screen here for a little cheat sheet. This is the shape, that's what it's called. So I've been referring to this as the icon. It's actually the thing you're seeing on the screen, but there's a bunch of different shapes that you can choose for your turtle. So I want to make mine turtle, but some other valid ones I think are circle, we have arrow, and then you're welcome to look up the other possible shapes that you have for turtle. I can't remember all of them, but I know that at minimum, 2 of them that exist are turtle and circle, and then obviously there is arrow as well. So sorry, those are the 3 that I know that exist. Okay, so let's change this to a turtle now, and let's see what happens this time when I run my program. I'm going to remove the sleep because I've slowed down the turtle, so hopefully we have enough time to see it now. So let's run this, enter some number, and now notice we get an actual turtle moving around the screen. Awesome, so that is good. Now I will show you how we can change the color of the turtle. So to change the color is pretty straightforward. You can say racer.color, and then inside of here, you can put a string that represents the color you want to change this to. So there's like a ton of different possible colors here. I won't go through them all, but for example, one is cyan. We could do red. We could do green. we can do blue, we can do yellow, black, orange, so on and so forth. So let's just change this to cyan. So let's run our code here. And notice that now we get a cyan turtle, and that the line that it has is cyan as well. Now, there's a ton of other stuff you can do with turtles. If you want to see all of that, I would just recommend you just look up turtle Python like that, and then you can see if you go to the turtle documentation here that there's a whole list of all of the possible stuff that you can do with your turtle. So I'll be showing you some of this, but I won't obviously go through all of it. Okay, so the next thing to show you is what is called turtle.penUp. So whenever the turtle's moving around the screen, you notice it was kind of drawing that line, right? And we're calling that the pen. So as the turtle moves, it's kind of a pen and it's drawing this line on the screen. Now, if we want it to not draw the line, but we still want it to move, we can bring its pen up. So we can say racer.pen up like that. And now you're going to notice when I run this program after I've moved the pen up is that as we move this turtle around the screen, no line is being drawn, right? Because its pen is up. So what I can do is I can move the turtle with its pen up, I can put its pen down, and then I can continue drawing. So let's copy this line. Let's move the turtle forward by 100, left by 90, and then let's put its pen down. So we're going to say racer.pen down. So let's do this now. Python here, and now notice that as soon as it turns that corner, then the pen goes down. So all this stuff I'm showing you, you can change at any point in time. You don't have to change it before the turtle starts moving or something like that. All right, so now I've showed you pretty much everything I need to in terms of the different methods for the turtle object. Just keep in mind, you can make as many turtle objects as you want. So I said racer equals turtle.turtle. I can make a second turtle, right? Say racer2, and then I can move these turtles in different directions. So just to give you a quick example, we can copy all of this, and then we can just change this to be, say, racer2. And we'll just make racer2 a different color. So instead of cyan, we'll make it, say, brown like that. Maybe we'll make it speed a bit faster, and then we'll change it so it goes forward like 150, just so you can see the difference in these two turtles. So let's change that to be 150. Again, notice I just had racer2. We can kind of copy this and put it down here to separate these things out. All right, so let's try this now. So let's go Python turtle race tutorial.py. Let's enter a number of racers, 3, and then notice the first racer is going to move around, and then our second guy kind of started moving really quickly, right? Because we wrote all of this code after we wrote this code. So I'm going to delete all of this, just wanted to show you that. And now what we are going to do is we're going to pick the colors of the different racers that we have. So once we know how many racers we have, we need to kind of create all of these turtle objects, and we need to pick their colors. So I'm going to create a list of colors up here in all capital, and I'm just going to type out a bunch of them. I have a list on my other monitor in case you see me looking over there. So I'm going to say red, we're going to say green, we'll say blue, we'll say orange. We have, if I can get my cursor here correctly, yellow. We have, what's another one? Black, purple. We then have pink. And did I do yellow? Yes, I did. What's the last one we have? Brown and cyan. Okay, brown and then cyan. Now note that there is a lot more colors in this. I'm just doing 10 for right now, so we can have at most 10 turtles. So now that we have all of these colors, we kind of need to pick, after we've gotten our number of racers, what turtle colors we actually want to use. So I'm going to show you a cool way that we can do this. So we can randomly select a bunch of colors from this color list that are unique. So at the top of my program, I'm going to import random. All of these modules are built into Python. You don't need to install them or anything like that. And then down here, what I'm going to do is I'm going to say random dot shuffle, and I'm going to shuffle my list of colors. So all this capital list right here. Now, what this is going to do is it's going to take the list and just randomize all of the items inside of it. So I have no idea where these items are going to go, but all of the items that I have here will just be kind of randomly placed around in the list. Then what I'm going to do is I'm going to select the first number of racers item from this list that are there, and we'll use that as our colors. So I'm going to say colors is equal to, and then colors, and then this is going to be a slice up to the number of racers that we have. So let me just quickly explain this. We've gotten the number of racers, we've initialized the turtle, we're shuffling that colors list, so just randomizing the order of all the elements there. And then what this does is this gives us the first racers item from the list. So if we had a list, say 1, 2, 3, comma 4, and then we put this little slice operator, this is what it's called when you use the colon, and we set up to, say, 2, what this would give me is the first 2 elements in this list. So I would get a new list that looks like 1, comma 2. Now, if I did the slice of, say, 3, then this will give me the first 3 elements. So 1, 2, 3, that's kind of the basics of a slice. So the reason we're doing that is we're randomizing the list and then just taking the first, say, number of elements. That number is equal to whatever the number is the user types in. So now let me show you this. We're going to print the colors after the user types in the number of turtles they want to race. So let's do this. Python turtle race. Let's insert 5, and then notice it kind of popped open that turtle window, closed it, and then it printed yellow, purple, green, orange, brown. Now, if I do this again and I type 5, you're going to notice we get different colors, right? And they're in a different order. So black, red, orange, brown, cyan. Now, this 100% will always select unique colors for us, so we'll never have turtles that have the same color. All right, now that we have all of the colors, we want to create all of these turtles. So we're going to make a new function here. We're going to say define and then create underscore turtles. Now inside of here, we're going to create a list of turtles, and then we are going to kind of place them on the screen in their starting position. So ideally, we want to have all of the turtles evenly spaced out at the bottom of the screen and kind of pointing upwards, ready to start racing. So let me show you how we do that. Well, the first thing that we need to do here is we need to determine what colors our turtles are going to be and how many turtles we're going to have. So this function as a parameter is going to take in colors. So we are going to pass this function when we actually decide to call it the number of colors that we have. And then what that's going to, or not the number, sorry, just the colors that we've actually selected. And by having this list here, we will also know how many turtles we have because the number of elements in this list will tell us the number of turtles that we want to race. So now what we're going to do is we're going to say that turtles is equal to an empty list. Then we're going to loop through all of the colors that we have. And for every single color, we're going to create a turtle and add it into the list. The reason I'm creating a list is because I don't know how many turtles I'm going to have, so I can't just define variables with like, I can't define 4 variables for 4 different turtles or 5 variables for 5 different turtles. I need to kind of dynamically create these turtles because again, I don't know how many I'm going to have. So I'm going to loop through now all of my colors. I'm going to say for I, comma, and then color in enumerate. And this is going to be colors. And what enumerate does is it gives me the index as well as the value of all of the elements in colors. So if I'm looping through colors, let's say like red and then green, then what's going to happen is on my first for loop iteration, I will be equal to 0. That's the position of this color. Color will be equal to red. And that's great. Then on my next iteration, I will be equal to 1 and color will be equal to green. And if I had one more iteration, say this was blue, then I would be equal to 2 because this is the third element or the second index / position. And then the color will be equal to blue. So that is what enumerate does, gives us both the index and the value. Now what I want to do is create a turtle. So I'm going to say racer is equal to, and notice you can name these variables whatever you want. And I'm going to make this equal to turtle.turtle, just like we saw previously. And then immediately I'm going to change the color of this turtle to be whatever color this is. So I'm going to say racer.color, and I'm going to make this, if my Sublime text stops crashing. Okay, it's crashing, so I'll be back after this stops crashing. All right, so I am back. That was really annoying. Sublime text just crashed on me, but I have eraser.color, and I'm going to set this color to be equal to color. The reason I'm setting it equal to color is because this will be a string. This string will come from this list of colors right here, and so every one of our racers will be a different color. Then what I need to do is set a few other things. I want to set the shape, so I'm going to say racer.shape, and this is equal to a turtle. Then what I want to do is place this racer in its starting position. Now, before I do that, I'm going to show you where they are placed initially, but I also want to turn these racers. So I want to say racer.left by 90 degrees. Now, the reason I'm doing this is because by default, the kind of arrows or whatever are pointing to the right. So if I want them to point upwards, because I want to race my racers upwards and my turtles upwards, then I need to turn them left by 90 degrees. So I'm going to take my racer, or make my racer, which is just a turtle. I'm going to set its color. I'm going to set its shape. I'm going to set its kind of heading so it goes in and is facing upwards. And then I'm going to add it to this list. So I'm going to say turtles.append, and then I will append my racer. This way, I have access to all of my turtles, and then later on, I can actually say move these turtles forward, right? And we'll move them by a random amount, and that will kind of simulate these turtles being raced. Now, I'm just looking at my other screen here. One more thing that I'm going to do here is I'm actually going to put my racer's pen up. So I'm going to say racer.pen up. I'm then immediately going to say racer.pen down. And inside of here, I'm going to set the position of my racer. So we'll just say set pause, and we'll do that in 1 second. All right, so now let's run this code here. So Python turtle race tutorial.py, let's insert our number, let's say 3. And what happened? Well, we need to call this function if we want to see anything happening. So after we get our colors, let's call create turtles, and let's pass our colors. So now we'll have all the colors here. We'll loop through them and create our racers for each. All right, so let's run this. Python turtle race, let's go 5. And notice when I do this, it kind of spins up 5 turtles. They spin to the left. They're all different colors, and then it's done. So obviously this is not ideal, right? All of my turtles start in the middle of the screen, and so I need to move them so they are at the bottom of the screen. Now I could move them like backwards, turn them left, move them to their correct position, but that's kind of a pain. So there's this method for our turtles called set position. Actually, let me make sure it's called that. Yes, it's called set pause. So racer.set pause, and this takes an X and Y value and will set the position of your turtle to, well, this position. So this is why I'm putting the pen up, then I'm going to set the position, then I'm going to put the pen down. So when I move this turtle to its position, I don't draw a line from the middle of the screen to wherever it goes, because that's just not optimal. That's not ideal. That's not what we want to do here. So inside of set pause, I need to choose an X and a Y value for my turtle. Now the Y value is pretty easy because all of my turtles will start at the same Y, and then they'll kind of increase their Y as they race upwards. So we know what the Y value will be, or we can just pick some random Y value, but what is the X value going to be? Well, I want to space these turtles out completely evenly, right? So let me open up my kind of Windows ink pad here. Where even is Windows ink? Okay, so I've just opened up Paint here. I unfortunately couldn't find the Windows ink thing that I normally use. I don't know where they would have hid it from me, but anyways, apparently it's gone. So go easy on me. I'm just using my mouse, but I'm going to illustrate what we're going to do here. So we have our canvas, right? Now our canvas is of size 500 by 500, but to make math a bit easier, we're going to say it's 400 by 400. Again, my mouse is really hard to draw with. Okay, so 400 by 400. Now we want all of our turtles to kind of be placed near the bottom of the screen. So to pick this position is pretty easy. We can kind of just take like the height of the screen, we can divide it by 2, we can add a small value to it, and then we'll say, all right, well, that's where we want to place the turtles at that negative coordinate. Because right here in the middle is 0, 0, right? So as we go down, this is negative. So if we place that negative 200, they'd be like right at the bottom of the screen. So we can move it up like 10 pixels, and then that would bring us to this kind of red line that we have right here. Now the question becomes though, what are the X values of our turtles? So obviously we want our turtles to be kind of spaced out. If we have 2 turtles, we probably want them somewhere like here and here, right? We want them equal distance from each other and then equal distance from the edge of the screen. Now I know this isn't exactly equal distance, but hopefully you're kind of getting the idea. Now if we have 3 turtles, we want one guy in the middle, one guy here, and one guy here. This way they're equidistant from the edge of the screen and from each other. So how do we figure out the X positions? Well, what we actually need to do is we need to figure out, first of all, the spacing between our turtles. Then what we can do is we can start our first turtle at whatever the spacing amount is. We can then add whatever the next spacing is to our next turtle, and then our next spacing, and so on and so forth. So how do we figure out the spacing between the turtles? Well, we actually take this number right here, which is the width of our screen, and we divide it by the number of turtles that we have plus 1. So I want you to see this example. If we take 400 and we have 4 turtles, a lot of people would say, well, the spacing between each turtle should be 100 pixels. Now, the reason why that would actually be incorrect is because that would assume the first turtle starts at the far left-hand side of the screen. So if I put my first turtle right here, and then I go 100 pixels over, my next turtle is at position 100, right? If we're talking about the X. Then my next guy comes over here and he's at 200. And then my next guy comes here and he's at 300. It's really hard to do a 3 clearly. This is my attempt at a 3. Okay, so 100, 200, 300, and then this first guy's obviously at 0. So we don't want that. We want to kind of shift this whole line over so there's equal distance between all of the turtles and the edge of the screen. So what we really need to do is we need to divide this number by 5, and then we need to start our turtle at the first spacing position. So if we take 400 and we divide this by 5, oh god, this is testing my math skills. 400 divided by 5 should give us a value of 80. Yeah, I think 80 is correct. 8 times 5, yeah, 40, 400, yeah, okay, 80 is correct. So now if we do this at 80, let me kind of erase all of this here. We'll say that our first turtle gets placed at position 80. So the first guy goes right here. Should I even attempt to do an 8? Okay, we have 8, 0. Then our next guy is going to go at 160, and then we'll move over again. And then our next guy is going to go at 240. Our next guy will go at 320, and then this will be perfect. We'll have our 4 turtles. They'll be equidistant from the edge of the screen and equidistant from each other. Now, I know this seems like they're not equal distance because I've kind of drawn this not to scale, but that's the idea behind this. So hopefully this long explanation gave you the idea of what we're doing. We're going to divide the value that we have here by the number of turtles plus 1. Then we're going to place the first turtle at spacing position, so whatever the spacing is, so starting at 80, the rest of them will go up by the increment of spacing every time. So we'll leave that kind of open in the background in case we need to refer to it again, but this means we are going to set the position, and we need to figure out the turtle spacing. So I'm going to say spacing x is equal to, and then the len of colors, this is the number of turtles that we have, right, plus 1. We're going to put these in parentheses, and we're going to start by dividing the width by 2. So we're going to say width divided by 2. Sorry, not width divided by 2. Width divided by the len of colors plus 1. So whatever our width is, we divide it by the number of turtles plus 1, which is really just the number of colors that were given to us. And there we go. So now, where do we want to start placing our turtles? Well, what I was showing you before is I was saying we're placing at 0, 80, so on and so forth. The only issue with that is that when we're at the left, so we're to the left of the middle of the screen, we're at a negative coordinate, right? So really, when we're drawing the kind of coordinate axes here, this is 0, 0. So as we're over here, we're in the negatives. So that's fine. All that means is we need to add the negative width over 2 as our starting position to all of these right here. So the first position for our turtle will actually be at negative width over 2 plus this value right here. The reason that will work is because we will subtract this by negative 200. And then negative 200 plus 80, that will be equal to, what is this, 120, negative 120. Then we will go and be equal to negative 40. Then we will be equal to 40. Then we will be equal to, what's 80 plus 40, 120. And that will work. And that will still give us the equal distance. And it will just kind of translate everything over to the left, which is what we want it to do. So hopefully that's making sense. We just need to account for the negative coordinate system. So we're going to set position at negative width over 2. And then we're going to add to this I plus 1. Let's guess why we need to do that in a second. Multiplied by, and then the spacing x. So this will be our x position. And our y position will be equal to negative height divided by 2 plus 20 pixels. Now, this is kind of an arbitrary value I'm deciding. I'm saying we want to be 20 pixels from the bottom of the screen. So we take the negative height divided by 2 and add 20. The reason we have the I plus 1 is because we start indexing at 0, so the first color is 0. Really, we want to make that 1 because remember, we want to place the first turtle at the first spacing position. So negative width over 2 plus whatever the spacing x is, that's where the first turtle should go. Then the second turtle, well, that will be a 1, so that will give us 2, so then we'll be at the second spacing position. Then the third, then the fourth, so on and so forth. So this should place our turtles in the correct position. Let's see if it does so. So let's run our code here, and let's say we want to have 8 turtles. So when we have 8 turtles, notice that now we're going to move the turtles. They are perfectly aligned on the screen, and they have equal spacing between each other and between the edges, so that's awesome. Now all we need to do is just return our turtles like that. And now that we've created the turtles, we've placed the turtles, we've picked our colors and the number of turtles that we have, we can start finally racing them on the screen. All right, so now what I'm going to do is create a new function. I'm going to call this function race, and this function race is going to take in our colors. Now I'm going to change kind of the flow of our program a little bit. Let me zoom out here so you guys can kind of read more of what's going on. So right now what we're doing is we're getting the number of racers, we're initializing our turtles, we're picking the colors, and then we're creating the turtles. That's great, but I don't want to create my turtles until I'm ready to race them. So I'm going to take this create turtles kind of function call here, and I'm going to put that inside of this race function. Now, the idea is that we're going to pass the colors to race, and then race will create our turtles for us. So we'll say turtles is equal to, and then create turtles, because this function returns the turtles. So then inside of here, we will create all of the turtles using our colors. And the reason this is important is because I want to know what color every turtle is. And by having access to colors and turtles, I can do that. So now rather than calling create turtles down here, we're just going to call race. So we're going to say race and then colors, and then this will create our turtles for us. And then in here, we can race them. So after I create my turtles, I want to start racing them. I want to start moving them. So I'm going to say while true, and then I'm going to move all of my turtles one by one. Now, the idea behind this is that we don't know how long it's going to take us for our turtles to get to the top of the screen. So what I need to do is have a while loop because I need to keep moving them until eventually one gets to the top of the screen. So inside of here, I'm going to say for racer in turtles. And then what I'm going to do is move this racer. So I'm going to say racer dot and then move. And sorry, this shouldn't say move. This is actually going to be racer dot forward because it's now facing the correct direction. It's facing up. So when I move it forward, that's the direction it's going to go in. So racer dot forward, and then I want to move it forward a random amount. So I'm going to say move is equal to, or maybe distance is a better variable name. Distance is equal to random dot and then rand range. And inside of here, we're going to put the minimum and maximum amount we want the turtle to possibly move at every iteration. So I'm going to say 1, 20. And what this means is every time I decide to move my turtle, I'm going to move it by either 1 or 20 pixels, or sorry, between 1 to 20 pixels. So it will randomly generate a number that is between 1 and 20 and move the turtle that amount. That's what rand range does. So you can make these values whatever you want. The larger you make this minimum value, the faster your turtles are going to move. And obviously, the larger you make this one, the higher probability your turtles are going to move faster. But really, this minimum value will dictate kind of the slowest speed of the slowest turtle, right? So just keep that in mind. I like to keep it at 1 so that the race kind of looks like they're like kind of inching forward rather than having big jumps every single time. Anyways, we're going to say racer.forward. We're going to move it forward the distance. Now, once we've moved our racer forward, what we want to do is check if this racer is kind of past the finish line. So the reason we're looping through all of the turtles, first of all, is because we need to move every single one of them. We have a list of turtles, right? We've created all of these turtles here, stored them in a list. Now we need to move every single one of them. So we loop through all of them and then we move them. Now, for every racer, we check if it's past the finish line. So I'm going to say x, y is equal to racer.pause. What this does is give me the position of this turtle. So I know the x and the y. I don't care about the x. I just care about the y. I'm going to say if y is greater than or equal to, and then height, and this is going to be divided by 2, and we'll subtract 10 here, then what I want to do is I want to say that this turtle crossed the finish line, that it was the winner. So to do that, I'm just going to return this turtle's color. So if this turtle passed the finish line, then it is the winner. What this function is going to do is it's just going to return whatever the winning turtle is. It's going to return the color of the winning turtle. So we'll say return, and then here we will return, and this is going to say colors at index I. Now, this may be a bit confusing, but the idea here, and oops, index I can't even use that. Okay, I'm going to show you a different way to do this. I thought I had coded this in a different way. I'm going to say colors at, and then this is going to say turtles.index turtle. So this may be a bit confusing if you guys haven't worked with lists before, but this is the rationale. We want to find the winner, the winning turtle color. We want to know the color of the winning turtle. So to do that, we need to access its color. Now, I don't think there's a way to get the color of a turtle from the actual turtle object. I may be wrong on that, but all we have access to here is just the turtle, right? We have the turtle that we're moving. That's all we have. So this kind of turtle.turtle, that's all we have. So the question then becomes, okay, how do I find the color of it? Well, I have the colors of all of my turtles here. So what I can do is I can find which turtle or the index of the turtle that was the winner, and then I can use that same index to figure out the color of it in this colors list. So think of it this way. If I have a list of colors, I have like blue and red, and then I have my 2 turtles, right? So let's just say I have turtle 1, and I have turtle 2. Well, turtle 2 is at index 1, right? So we have index 0 and index 1. So turtle 2 is at index 1. So if I can find the index of this turtle, all I have to do is reference that same index in my colors list, and that tells me the color of it, right? Same thing for turtle 1. Well, turtle 1's at index 0. Its color must be index 0 in the colors list. This expands with any length of turtles. So what turtles.index does is, notice this is the name of the list. I'm then passing the turtle that I'm looking for the index of. It tells me the index of this turtle. So, and sorry, this should be changed actually to be racer. That's my bad. I was probably confusing you guys there. But we have access to the turtle. So we say turtles.index racer gives us the index of this turtle object in the turtles list. We then use that same index on the colors list to reference the color of that turtle, and we return it. So not really much more I can explain there. That's probably the best that I can do for that. We're going to return the actual color. Now that we have the color, down here, we'll say winner equals race, and then we can just print out winner. The idea being that this function is only finished once we return this color. So just in case you're aware, or just in case you're unaware, sorry, in a while loop, whenever you return something, or just in a function in general, as soon as a return statement happens, the function immediately stops. So even though this is inside of a while loop, the while loop will stop running as soon as one of the turtles has won. So let's just run this code. Let's just see if this works, then I can explain to you some more kind of details about this. So let's go here, Python turtle race. Let's go with 5 turtles. So we're going to create our 5 turtles, and then they're going to start racing. So they kind of start racing up the screen. Notice that they're drawing every single time, and then boom, it says pink. The reason it says pink is because if you saw, pink was the first turtle to cross the finish line. Now it's worth noting here that there is a little bit of a bias in the first turtle. So the very first turtle has a very, very small probability of finishing earlier than all of the other turtles. Like it has a better chance of doing that in a sense because it's the first turtle that we move. We have to move the turtles sequentially. Like we can't move all of them at the exact same time. So we move the first turtle, then the second turtle, then the third turtle, then the fourth turtle. We check if any of them are past the finish line. Whatever one crosses first, we say that's the winner. So it's just a higher probability that the very first turtle we move will finish first. So the last turtle kind of has, the least chance of winning. But based on this randomness here, it ends up kind of counteracting that in some type of sense. So hopefully you get what I mean. I'm not going to worry about that for this problem right here. If you guys were concerned about the fact that one turtle has like a little bit of bias, which it kind of does, what you could do is you could see if one turtle crossed the finish line, and then if a turtle crossed the finish line, you could still move every other turtle, and whatever turtle moved the furthest, so was like the furthest past the finish line, that's the one that you would say would be the winner. There's no way other than that to really kind of fix this problem. So anyways, that is really all we need to do here. Like that is it for this program. So the last thing I'm going to do is I am going to print out in kind of a nicer way what the winning turtle is. So I'm going to say the winner is the turtle with color, colon, then comma, and I will say winner. So that's all we'll do. So now we just have a nicer kind of output message saying this was the winning turtle. And then I'm going to say time.sleep. And I'm going to sleep for 5 seconds just so that we have a few seconds to actually see which turtle was the winner before we just go ahead and close the program. So hopefully that's clear. But yeah, that's really all we need. So let's run this. Let's go with 10 turtles this time, and let's see what we get. Let's just enjoy the turtle racing show. Okay, so they're going to race. You're going to notice the more turtles you have, kind of the slower they go. Just because we have to move every single turtle one at a time, we can't move like a bunch of turtles. Like the more turtles we have, the more we have to move, and so the longer it takes to run. That's what I'm trying to say. But we saw that the winner is the turtle with color green. Let's run this one more time with 2 turtles, and you'll see that it goes like way faster because it's just these 2 guys that need to move. Purple was the winner. And then if we kind of go back into CMD, it says the winner is the turtle with color purple. Awesome. So I think that's really all I need to show you here. Now, all of this code will be available to download from the description in case you got lost or something's not working, but hopefully I did a good job at explaining a lot of these concepts. Hopefully you guys kind of learned how you can lay out a, I don't want to say large, but medium-sized Python program that has more than just a few lines of code, and you get the idea behind these functions, right? So now at this point, if I want to go change something, like say I want to change the width of my screen, since I use this width variable everywhere in my program, and everything I did was very dynamic, right? I had like height over 2. I had width over 2. If I change the width up here now, everything will just work, right? Like if I change this to 700 and I change the height to 600, doesn't even have to be square. Let's just run the program again. Let's go with 6 racers, and it's still going to be evenly spaced out on the screen. Right? Just because the way we did this is everything was dynamic, it used the variables, and we set it up in a way where if we made any changes later on, it wouldn't completely ruin or mess up our program. And what does it say the winner is here? The winner is turtle with color blue. So just keep that in mind. Hopefully you appreciate that kind of detail in writing this code. And same thing here, even with like validating the input, right? We're going to keep asking the user for a valid input until they give us something that's valid. And then race, we're using another function. Inside of this function, we could have just taken whatever, all of this code and placed it inside of here. But if we did that, then if we wanted to change the way that we were creating our turtles, well, we could do that, but it would just be a little bit harder. And if we wanted to say use this function anywhere else, same thing, just wouldn't work as well. So this way, it's really easy to see, laid out very nicely. And this is just a better style of coding than writing everything in one line, right? Because we could have written this entire program in just one line, like we didn't have to use any functions. It could have just all been in the main line of the program, but then it wouldn't be very clear to see what part of the program was doing what. Awesome. So I hope you guys enjoyed. If you did, make sure to leave a like. That's really all I have for you today. So subscribe to the channel, and I will see you guys in another YouTube video.